Welcome to Unit 2, Lesson 2. You'll notice that it says on the screen there that this is Part 1. I am not sure at this point exactly how many parts I want to have for Lesson 2, but it will be at least 3, maybe more than 3. So for this particular lesson, our standards are to solve and graph mathematical and real-world problems that are modeled with quadratic functions. So we're continuing to stay with quadratics. We're going to be with quadratics for a long time. Interpret key features and determine constraints in terms of context. So that will have to do with the word problems that we work with. And it just means that things might be limited by time. Like say, for example, we don't have negative time in our problems. And then compare the key features of two functions, each represented algebraically, graphically in tables or with written descriptions. So that is where we are headed, and that's what we're covering in this particular lesson. So this class will start off with a Desmos exploration, and we'll do this for quite a bit of time at the beginning because I really want you to explore. So if you're watching this video to make up the material at home, I want to be clear about what the goal of this particular activity is and give you a chance to pause the video to do this on your own. So for this, you will be exploring the relationships between functions and their graphs. So when you graph a bunch of functions, okay, the numbers that appear in the function or in the like a function equation have a connection to what you see on the graph. They're not random. So when you see something like a -2, that means something for what the graph does. And so I've broken these up into 3 groups, group 1, group 2, and group 3. And you can tell by looking at them that the functions in each group have certain things in common. So the first group, you've got some stuff in parentheses, and the parentheses are squared. The second group has 2 sets of parentheses. And then the third group, what you'll notice in the third group here is that it's x squared plus 2x for all of them. And then what's changing is that number at the end. So what I'm driving at with that one is I want you to figure out what does that number at the end do. So what I'd like you to do, even if you're doing this from home, because it's important for you to explore and to handle the material, is pause the video, take maybe a quick picture of what these functions are. And I know this one down here, you can't see what that last number is. It looks like it's probably a 6. So you can use a 6. You can get the point of the activity either way. And then go click over to Desmos and graph these and make some notes. What do you notice about the numbers in the equation and what you see in the graph? Okay, and then unpause the video when you've had a chance to do that, when you've actually written some notes, and then we can kind of look at what the discussion of that might be. I'm expecting this to take you in the vicinity of 15 to 20 minutes is what I think I will give students in class to do that. So go ahead and pause the video, participate in that activity, and then unpause the video and come back to this presentation. All right, so hopefully I waited long enough there. I don't want to give everything away in this video. Getting a text message. Because I do want you to do the activity and to not just rely on the video to tell you what it is you're supposed to see. I want you to actually see it. But with this first one, what I was hoping that students would see is the relationship between these numbers that I'm highlighting right here and the vertex of the parabola. And so we've actually talked about this in the previous lesson, where when you have your function in this particular form, then I have plans tonight, so my phone is going to blow up. Sorry about that. Yeah, when it's in this form, you can tell whether the function goes left or right or up or down, and that gives you the location of the vertex. And what you should also notice is that in this case, you have a +0, okay? And that's why you would have a 0 where the vertex is. But that this number right here, the sign is the same, and this number right here, the sign is flipped. So the vertex for the first one is -3, -2. The vertex for the second one is -3, +4, and so forth. That's a 4. There we go. For the second one, what I wanted you to notice out of this is that these numbers here tell you where the function crosses the x-axis, also known as the x-intercepts or the zeros. So what you would notice in that, we'll do the second one, okay, and that the signs are flipped. Okay, those are the two things I really want to notice. So looking at this one, it crossed the x-axis at 3 and at -4, okay, and probably did something that looked like that, okay, and that the signs were flipped. And so where you see a minus sign there, it ended up being a 3 over here, and where this was a plus sign, you ended up with it crossing at -4. So the signs were flipped, okay, but that the numbers in the equation corresponded to where it crossed the x-axis. And in the last one, it was the only thing that was changing was that last number right there, and that's obviously what I wanted you to focus on. Okay, the other ones are just kind of hard to see, and what you should have noticed on those ones is that that number corresponded to the y-intercept, and so this parabola right here crossed the y-axis at 3. Okay, and so you had it crossing the y-axis there. Now again, it's way better if you just let the video play through and said, oh, Miss Taylor will tell me what it is I should have seen. There's a massive difference between just listening to me give you information and you doing the activity and seeing those patterns for yourself and constructing, I guess like the educational jargon would be constructing that knowledge on your own. What I tell you, you are likely to forget. But what you see for yourself and what you connect together in terms of your ideas, that you are much likely to remember. So please don't take shortcuts with this. If you did, I'm strongly going to encourage you right now to pause the video and do the activity now. Like, go and see what these relationships are. Take the time to do it, please. It does make a difference in the learning aspect. All right, so this chart here is a summary chart. So we want to introduce some vocabulary. What we've got going on over here is the vocabulary: vertex form, factored form, and standard form. Okay, and those forms there, you need to know the words so that when you see in the directions something like here is a parabola or a quadratic in vertex form, change it to standard form. That you know what you're being given and then where you are supposed to go with it. That is just vocabulary. Now, each of these forms has a formula, and I put formula in quotation marks right there because I don't want you to, I don't know, default to memorizing formulas, but you do need to be able to recognize what they look like. So for the first one, and we've seen this before, the formula for vertex form is this. And okay, and I know we've covered that because students have asked me, why is that an H and a K? Okay, they're like, what is that? So you've got your value out in front, your A value, and that will control whether it stretches or shrinks. And then if it's negative, it will also reflect it over. And then you've got your left right shift and your up down shift, okay? Or your slide translation. We'll use all the good vocab there. And that form of the equation is called vertex form. So you can rewind the video, go back to the group 1. Everything in group 1 was in vertex form. Now, what does vertex form show us? Well, in short, vertex form shows us the vertex. Okay, and that hopefully makes sense. Although I've had students get that wrong on a test, like, what does vertex form show us? And there'll be multiple choice, and students don't pick vertex. Okay, remember math is supposed to make sense. So vertex form shows us the vertex. And if you want a little bit more explanation on that, it shows us the vertex because it shows us the translations. Again, those slides. And because it shows us whether the parabola is going left or right or up or down, it's moving that vertex point around. Okay. Now, the next form that you investigated is something called factored form. Now, that uses the vocab word factor. Factor are, what factors are, things, we'll use that nice specific word there, things that are multiplied. Okay, so factors are things that are multiplied to give us what's called a product. So lots and lots of words there. So when you're looking at something in factored form, what you're looking at is a form in which you have several things multiplied together. If it's a quadratic, it will probably be 2 or 3 things that are multiplied together. If it's what's called a higher order polynomial, then you might have more than 2 or 3 things multiplied together. So here's the form. Okay, once again, you might have that a value out front, and then would have something like x minus p and x minus q. And again, as with vertex form, when a student said, like, where are, where'd you get h or k from? They're just the letters that we use for that form to represent numbers. So you might have, x minus 2 plus 4. And the same with factored form. The P and the Q they're just the conventional letters that are used. They don't mean anything specifically, but it just represents the numbers that might be there. So for instance, you might have something like y equals x minus 3x plus 4. And so the p value would be 3 and the q value would actually be negative 4, because you'll notice that it's got a plus sign there, which would come from minusing a negative. Okay, but that's all the p and the q are. And what does factored form tell us? It tells us the x-intercepts. And that is the word intercept, I-N-T-E-R-C-E-P-T-S. Sorry that my C got a little bit messy there, okay? So intercepts. Now there's 2 other words for x-intercepts. They are also called roots and zeros. Okay, they are also called roots and zeros, and you will see all 3 of those vocabulary words used interchangeably. It's not like one of them is more common than the other. All of them are used, and I don't know which one is actually used on your test or what you might see on the SAT, so you do need to know all 3 of those. Intercepts, roots, and zeros. You might be able to figure out why they're called zeros, okay? Because the y coordinate would be a 0 for all of them. So, all right, and that's the factored form. And then the last one here is something called standard form, okay? And standard form you will be familiar with because you studied it in Algebra 1. And that is ax squared plus bx plus c. You might be familiar with that from something called the quadratic formula, which is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. My 9th grade math teacher made me memorize it, and it's still up there in my head. Okay, so that's standard form. And standard form is good for a couple of things. What it shows us, though, to answer the question there, is the y-intercept, which happens to be the c value. Okay, so that's what it shows us very quickly. But it is also good for, and I'm just going to write QF for the quadratic formula, which is the formula I just rattled off to you. So it's good for the quadratic formula if you need to solve a quadratic equation and you have it in one of the other forms here, you need to get it into this form before you can use the quadratic formula. And you can switch between forms. So that's something that this section kind of assumes that you already know how to do, which is not really a safe assumption. Some of the processes that you need to be able to do this are algebra 2 skills. So I don't really think it's safe to assume you know how to go. If you were given something in this form, that you would know how to go from vertex form to standard form, or go from standard form to factored form, or factored form to standard form. And going from standard form back to vertex form requires a process that you don't even know yet. So, but you can switch between forms, and sometimes the reason you switch between forms is because a different form will give you different information. Now, with free access to Desmos, you are able to get other pieces of information from it by going through the graph. So you could maybe take something in this form, graph it, and then the graph would show you the vertex, and so you wouldn't actually need to look at it this way. Or you could graph this and you could see the y-intercept without having to do the mechanics of switching back and forth between the forms. So knowing how to use Desmos is a huge, huge, huge asset when working with the different forms of the quadratics. So what is the skill that you need to walk out of today's lesson with? So that whole first part was very conceptual. We wanted to explore, handle the different forms, see what the different forms are good for, get familiar with what they look like. Now, the remaining lessons in this unit are going to focus on looking at each of those forms in more depth, as well as identifying the key characteristics from those different forms. So for today's lesson, we are actually going to focus on vertex form, okay? Which makes sense because that's the one that you are already familiar with. So because we've been doing stuff in vertex form, so it makes sense to kind of piggyback a short little section that you're already familiar with on top of the 18 minutes of new material that we just covered. So you should be able to sketch quick graphs from vertex form. Okay, and as an explanation as to why we're talking about like quick little graphs, many graphs do not need to be super accurate. Okay, we use certain key points to get a general idea of how a function behaves. So most of the time when we're sketching graphs, we're doing it quickly just to get a sense of where the function is and what it does. And we need certain key points to be able to sketch it, but we don't need to get all the points. Now, if you need your graph to be super accurate, then what you'll do is you'll kick on over to Desmos or a graphing calculator or something else, because they can handle that accuracy. So what we're going to work on in this lesson is just sketching some quick graphs. Now, once you have the graph, I want you to be able to state the following. The vertex. This is a review of the last lesson. You've already done that, so hopefully that goes really well. If you missed it in last lesson was confusing, this is a reteach of it. I want you to be able to state the axis of symmetry. And just as a quick review of what that is the vertical line through the center of the parabola. Okay, vertical line. And it will take the form x equals. We covered that in a previous lesson. And then I want you to be able to state something called the minimum or the maximum. Now, you're all familiar with the words minimum and maximum, and you might think minimum is lowest, maximum is biggest or highest. Okay, minimum might be smallest. So here's the definition. The minimum or maximum value is the highest or the lowest, depending on which one you are finding, Y value that the graph reaches. Okay, so it's one number. It is one number, and it is the number that you want is the Y value. Okay, when you are asked to state the minimum or maximum, your answer is going to begin with Y equals, because that's what minimum and maximum are defined as. Now, the Y value tells us the what? It tells us what the minimum or maximum is, and what you can't see behind my head there is the X value tells us where the minimum or maximum is. So where on your x-axis will you find the minimum or maximum, and then your Y value tells you what that minimum or maximum is. So you got the where and the what. So for our first example, we're going to do 2 examples, and then you're going to be released to do 2 practice. So we've got over there the function y equals negative and then x plus 3 all squared plus 2. So what probably will help is to go through the transformations, which we covered in the last lesson. So what we know is we know that that negative is going to flip the parabola over. So it's going to look something like that. We know that a plus 3 inside the parenthesis is going to make the parabola go left 3, and the plus 2 is going to make the parabola go up 2. If you need a review on that, you want to go back and look at the last lesson, lesson 1, where there's a big old chart at the beginning of the lesson on what the transformations are. So to graph this, I'm going to come over to my coordinate plane. I'm going to go left 3, up 2, and then when I go to sketch it, I'm just going to make sure that my parabola is flipped over. So left 3, 1, 2, 3. Here you can see what I'm doing. Left 3, so I'm going to go 1, 2, 3, up 2. So that's where my vertex is going to be, and then I'll draw my parabola looking like so. So left 1, 2, 3, up 2, there. Okay, and that's all we mean by sketching a graph. It's a very quick graph that shows us key things. Now, in this particular type of problem, those key things are the vertex, the axis of symmetry, and whatever the minimum or maximum is. Remember that vertex is a point. It is a location. It is, in this case, that location. Okay, this might be easier with the highlighter. It is that. You know what? Just that this is just not going well. Left 3, up 2, and then there we go. Okay, and your vertex is right there. Okay, it's a little bit better. So when answering the question, what is the vertex, make sure that you give the ordered pair, which in this case is -3, +2. The axis of symmetry is the vertical line that goes straight through the center of the parabola. The axis of symmetry, because it is a vertical line, starts with x equals. And where does it go through the parabola? At x equals -3. Now, in earlier recorded lessons, so you might have to hunt back in Unit 1, I do go through the equation of a vertical line and why it starts with x equals. instead of y equals. Now for the minimum or the maximum, that is the highest or the lowest point that the parabola reaches. Well, in this case, if we look at it, there is a highest point, and that highest point is y equals 2. Now, incidentally, when we talk about domain and range, the range for this, because remember range is your y values, your range would be y is less than or equal to 2 because it's at the 2 and then it goes down from there. Okay, so if you want to make that little supplemental note on the range, I know range isn't something that we were covering specifically in this lesson, but it is beneficial to kind of go over that. And the domain is all real numbers because when it comes to the x's, it never stops or turns around. All right. Example problem number 2. Here we go. We'll look at the transformations first. So there's nothing out front. It is not stretched, compressed. It does not flip over. So we don't have any of those transformations. We know that it is going to go right 4, but it does not go up or down at all. So all we're going to do is count right 4. 1, 2, 3, 4, and then draw the parabola as it was before. So something like that. That looks a little bit too pointy. I might nail you for that on a test if you sketch it quite like that. So let me do a little bit better myself. Okay, and then our vertex is right there. Okay, so answering the questions, our vertex is a point. So it is at the point 4, 0. We go right 4, up 0. That's like all we did. We just went right 4. The axis of symmetry is running straight through that parabola, right through the middle. And remember, axis of symmetry, it starts with x equals, and it, what is it here? X is equal to 4. Okay, now minimum, maximum. Minimum, maximum is the highest or lowest point that the parabola reaches, which in this case is y equals 0. And it is the lowest place. So in this case, it is a minimum because it's the lowest place on the parabola. And just to reinforce that range is your y coordinates because the parabola is going up. We would say the range is y is greater than or equal to 0. Okay? And the domain is all real numbers. So rewind if you need to hear the explanation again, or you need to write something supplemental down in your own notes. And when you're ready, move on to the 2 practice problems. And here they are. So pause the video, take some time, actually figure out, what you would answer, sketch your little graph. It shouldn't take you a super long time to sketch a little graph. Identify the vertex, axis of symmetry. This is low risk. Worst thing that can happen is you end up getting them wrong, and then you have to hear the explanation to figure out, okay, what did I get wrong and how can I fix it? Yeah, low risk. So pause the video, try these 2, and then unpause the video and we'll go over them. All right. Hopefully I waited long enough. Let's go over these puppies. So for the first one, we are going right 2, and I don't know why I switched the direction of my arrow. I can't handle it. And down 3. So on my coordinate plane, I'm going to go right 2 and down 3. There's no flip on that. So right 2, down 3, right about there. And just so we can be really clear about where that vertex is. Okay, vertex is right there. So right 2 down 3. So the vertex is at 2, -3. Our axis of symmetry is running right through the center, and it's running right through the center at x is equal to 2. And the minimum value, and it is a minimum on this one, is the lowest point that it reaches, which is y equals -3. So if you got anything wrong, okay, make the corrections. Now, what you're probably noticing is that there seems to be some patterns going on here, that once you identify the vertex, those are the numbers that are turning up in your axis of symmetry in min-max. This is true, but I don't want you to just memorize copying numbers. It's important that you know what you're finding, that axis of symmetry, and that it's like a min-max, what that is and where it's located on the parabola, because I can always twist the questions a little bit, okay, and ask you, just show you a graph and say what's the minimum or the maximum and so forth. And you need to be able to weave your way around the problems differently. So make sure that you are focusing on the concept and the vocabulary, not just on a procedure for copying down numbers. You will forget your procedure for copying down numbers. All right, next one. We'll use red for this one. So for this one, there is a flip over the x-axis. We are going to go left 3, and we're going to go down 2. So counting left, 1, 2, 3, down 2. So my vertex is going to be right there, and it's going to be flipped over. So left, 1, 2, 3, down 2. So right there. Okay, something like that. And again, I'm not really happy with that, just because I'm really picky with you guys about making sure that they're not pointy. And then it's just looking a little bit too pointy for me. All right, so the vertex for this one, we went left 3, down 2. So the vertex is at -3, -2. The axis of symmetry is running right through the center there, and that is going to be at x equals -3. And in this case, it is a maximum, okay? And that maximum value is the highest y value. So the highest y value is y is equal to -2. If you did the range for these, so you're like, I'm going to practice that range. I know range is coming back. For this one, if you did it, the range would be y is greater than or equal to -3. And for this one, the range would be y is less than or equal to -2. Okay, you weren't asked to do the range, but if you did it because you're like, I'm going to practice it and just see, and then you'd be upset with me if I didn't give you an answer to it because you want the answer. All right, last little piece of the lesson here is your homework. So your homework is located in OneNote under today's lesson. So go in, find, Unit 2, Lesson 2A, and then you should be able to find the homework. It is from page 77. I just said 77 plus. 77 is where the problem set starts. And so 1, 3, 5, 7, and then 13 through 16. Do quick sketches of the graphs, just like we did in this lesson, and then check them in Desmos. Make sure that you got your sketches right. Be prepared to turn the assignment in at the start of next class. And if you're interested in the rubric for how they are graded, that is in the video from the last lesson. It's at the very end of the last lesson. So hopefully this was helpful for you to make up the lesson. If you missed all or some of it, let me know as always.